Hi everyone, welcome to today's lesson. Today we're going to start off with a warm-up, if only because we're going to be using these two skills later on in the PowerPoint, and I want to make sure we get the first round of explaining done right now. So go ahead, pause the video, and see if you can do these two problems on your own. All right, here we go. The first one is distance formula. This one should be familiar to you, but if you have forgotten, distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus 1 squared. Now, if you flip that around, did x1 minus x2, or that's fine, as long as it matches. So in mine, I did x2 first, which means y2 needs to come first. If you did x1 first, totally fine. Just make sure y1 comes first. All right, then when we go to do this, we have x1, y1, x2, y2, and we're going to plug this in. So distance is equal to -2 minus 6 squared plus -6 minus 2 squared. This gives us -8 squared plus -8 squared, which in turn gives us 64 plus 64. When we add these two numbers together, we get the square root of 128. Now, we need to simplify this radical, so I'm going to take 128 down here and split it up. Fortunately, I already know there's two 64s in here, so this is going to be 64 times 2. 64 is a perfect square, so this will come out, and d will be equal to 8 root 2. And that's distance formula. All right, let's move on to completing the square. This is an algebra skill that hopefully you learned when you were going over factoring. If not, here we go. Now, before I get to the actual problem, I'm going to back up and explain something. Completing the square. What does the title mean? It means we are finishing an expression called a perfect square trinomial. As a reminder, this is whenever you have an expression like x squared plus 6x plus 9. Okay? If we wanted to factor this, okay, what two numbers multiply to 9, add to 6? Well, that would be x plus 3, x plus 3, which would simplify down further to x plus 3 squared. You see how we have a parentheses, one singular term, so to speak, that is being squared? This is what we're doing in completing the square. We are taking a trinomial and turning it into a perfect square trinomial. That way we can factor it down. Now, the pattern behind this, maybe you can see it, is that you're going to take this, let's go with ax squared plus bx plus c is equal to d. Okay, you want to factor this all the way down, and then eventually it will factor down to ax plus b over 2 squared. If you're wondering where the b over 2 came from, well, let's look at our problem. We had 6x squared, and look in our parentheses. It's a 3. How do you get from 6 to 3? Well, you divide by 2. All right, and that's the pattern over and over and over again. Here's the other step of the problem. C is usually not there. You have to find C. So how do we find C? Good question. You take B, you pull it off the side and divide by 2. You then square this, and that gives you C. So go to our problem over here. We had 6 divided by 2 is equal to 3. You square 3, and that gives you your 9. Now, we'll go over all this a little bit more when we start the problems, but I just want to give you the background so you can see how these patterns work. Keep an eye, though, on b over 2 because it does come back and is our factored number. That being said, let's get started. So, first off, whenever I have a problem, I want to make sure it is in this format, where all of my x's are on one side of the equal sign and my regular numbers or my constants are on the other. So I'm going to add 21 to both sides. Now I have x squared plus 20x equals 21. Yes, I left a space on purpose. All right, so now I'm going to complete my square. I'm going to make this a perfect square trinomial. I'm going to do that by pulling 20 off to the side and dividing by 2. This gives me 10. Keep an eye on 10. And then I'm going to square 10. 10 squared is 100. Now the golden rule of equations, what you do to one side of the equation, you must do to the other. So if I add 100 to this side, I must add 100 to this side. Now I'm going to factor. And if I did this right, it should factor down to x plus 10 is equal to 121. And as you can see, squared. As you can see, the 10 came back, and it is the number within the parentheses. Now I have a square, and I can take the square root of this. Not factor, take the square root. So I'll change colors. I'm going to take the square root of both sides, and now this is x plus 10 is equal to plus or minus 11. The reason why it's plus or minus is because 11 times 11 is 121. Negative 11 times negative 11 is also 121. So you got to have both answers. Subtract 10 from both sides, and I have x is equal to negative 10 plus or minus 11. Now those are both numbers, so I can simplify this further. I'm going to have two expressions. Negative 10 plus 11 and negative 10 minus 11. Negative 10 plus 11 gives me a 1. Negative 10 minus 11 gives me a negative 21. So that means that x is equal to 1 and negative 21. And this is how you complete the square. We'll come back to this a little bit later. Hopefully that helped you remember. That way when we get to the problems, it's a little easier. All right, now today's lesson is graphing. We are going to be graphing the circles, and therefore today we're going to be going over the equations of the circles. Here we have it. Now, the basic fundamental start from the beginning equation for a circle is r squared is equal to x squared plus y squared. Now, where does that come from? Well, it comes from the distance formula. So think of a circle. You have your center point, and you have a point on the edge of the circle. Look over here at the picture. The radius, by definition, is the distance between the center and the side. How do you find the distance between 2 points? You use the distance formula. And the distance formula starts off as Pythagorean theorem, which is why it looks so common right here. So you start off with this x and y coordinate, and that's where you get this. R squared is your radius, and x and y is any point along the edge of the circle. Please bear this in mind. X and y stay in the equation. All right, always leave x and y within the equation. Otherwise, you're going to lose your equation and you won't be able to graph anything. Now, with that being said, let's look at this equation up here at the top. The equation of a circle. So in it, we see r squared, we see x, and we see y. But what about this h and k? Well, if you remember back from algebra, h and k do transformations. H does horizontal transformations, left and right. All right, h is the one that moves things along the x-axis, or the x-coordinates. K does up and down. It moves things along the y-coordinates. Now, the reason why h and k are here is because they tell us what the center is. So h comma k is always going to be your center. It moves it from the origin. This equation starts at the origin. This equation, well, they're actually the same equations, but in the original equation, you have r squared is equal to x minus 0 squared plus y minus 0. But since you don't have to write 0, that's where the original one comes from. So h and k are always going to be where your center point is, and they will move things along the two axes. Let's do some problems. Here we go. Now you can see the picture, but I'm going to zoom in and ignore it for right now so we can talk about what's going on. So we are told that the center is at 0, 4, and the radius is at 3. We're going to write the equation and then graph it, and then we'll check with the official picture. So the equation is r squared is equal to x minus h squared plus y minus k squared. 0 is our h, and 4 is our k. Every single time the center is going to be h and k, and the radius is r. So we have this information, we're going to plug it into the equation. This means we're going to have 3 squared is equal to x minus 0 squared plus y minus 4 squared. And now I simplify. 9 is equal to x squared plus y minus 4 squared. And this is our equation. This is what we were going for if we just wanted to have the equation. Now, I'm going to take this equation and we're going to graph it. So, real quick, xy coordinate plane. And we're going to plot this. Always start when you're doing this with the center point. So I'm going to at first plot 0, negative 4, or 0, positive 4, which is right here. Then you're going to plot the 4 cardinal points. Cardinal points are your north, south, east, and west points. So I'm going to take this, and I'm going to start from the center. I'm going to go 3 up. So 1, 2, 3, there's my point. And I'm going to go 3 down. 1, 2, 3. Now left 3, or right 3. 1, 2, 3. 1, 2, 3. And then you can draw your circle. Looks a little more ovalish than I would like, but that's because my figure is not drawn to scale. If you want to use graph paper and make sure things are done properly, go for it. But you can see, aside from the fact that mine is smaller, it does match our picture over here. So always start from the center and then go up your radius, down your radius, left and right, and then you'll have the 4 points for your circle. Your turn. Just write the equation on this. You don't have to graph. Do both of these, and the video will play, and we'll show the answers and go over them. All right, here's the answer to the first one. So I showed all the in-between steps just so that you can see where things came from. You take square root of 10 and you square it, and you get the inside number of 10. Again, whenever you're centered at the origin, all you're going to have is x squared, and y squared. All right, do the next one. And here's your answer. Now in this one, pay attention to 2 things. Number 1 is the fact that when you plug things in, the equation is already negative. Okay, so in this instance, when we plugged in a negative 1, the negative that was already in the equation times the negative 1 gives you the positive 1 down here. Now this is obvious when you plug into the equation, but when we take out of the equation, remember that things are going to look backwards. Okay, if it looks negative, that means it's positive. If it looks positive, that means it's negative, because the equation is negative. Number 2, I want you to notice the diameter is 8, which means the radius is 4. Okay, so when you plug it into the equation, that means it's going to be 16. Always double check you're dealing with the radius. How'd you do? If you have any questions, put a mark by it and star it. In the meantime, let's keep going. Now, the first way that these problems will level up is that you will have to find the radius. So in the 3 previous examples, you were given the radius. Now we have to find it. The way you find it is by remembering that the radius is the distance between the center to the side. So we're going to use the distance formula to find our radius. Okay, so I'm going to have r is equal to, have this be x1, y1, x2, y2. And here we go. Square root of negative 2 plus 6 squared plus 4 minus 7. This is 4 squared plus negative 3 squared, 16 plus 9, which is the square root of 25. R is equal to 5. So now that we know R, we're going to find our center, which is right here. I'm going to take this information and plug it into the equation. So R squared is 25 is equal to X minus H. Okay, so that's going to be minus -2 squared plus Y minus K. Whoops. Y minus 4 squared. Again, the equation is already negative, so I'm going to simplify this. And I have X plus 2 squared plus Y minus 4 squared. And that's our answer. Your turn. See if you can figure this one out. When the video plays again, you'll see the answer. And here you go. So when you solve for R, you got square root of 34. Remember, the equation asks for R squared. So the square root of 34 is just going to end up being 34. And then you plug in the center points, the same way we've been doing. Now this is the first way the problems level up. The next way the problems level up is when you have equations that look like this. So please make sure you have this example written in your notes. I'm going to color code this one so that it's easier to follow along. But this is the equation where we're going to be using the completing the square problem that we learned at the beginning. So please make sure you are following along very closely. All right, here's our problem. Now we need to get this equation in the form of R squared is equal to X minus H squared plus Y minus K squared. Now, if you remember back from the warm-up, this notation right here, X minus H squared, this is the notation and what happens when you factor a perfect square trinomial. It'll end up in this format. So we are going to use the completing the square method in order to get the H or the X and the Y expressions to factor down into this. So here we go. First step is to rewrite everything. So I have X squared minus 8X, change colors. Then I have Y squared plus 2Y, one more time, equals -8. And yes, I left space on purpose. So now we're going to start with X. We're going to complete the square. I'm going to take my middle term of -8 and pull it off to the side. Then I'm going to divide by 2. It's going to be -4. Now keep an eye on -4. It's going to come back. But in the meantime, I'm going to take -4 and I'm going to square it. And this gives me 16. I'm going to add 16 to both sides of the equation. Because what you do to one side of the equation, you must do to the other side of the equation. Now I'm going to do the y's. Again, my middle term, which is 2y, 2 divided by 2 is equal to 1. Keep an eye on 1. In the meantime, 1 squared is still 1. So plus 1, plus 1. And now I'm going to simplify. Well, correction, now I'm going to factor. That's the whole point of doing this. So with the x's, this will factor down to x minus 4. Every time the number that goes in the parentheses will be b squared. Every single time. That's the way this pattern goes. Which means that the y1 will be y plus 1. You take the sign with you. Is equal to, this over here ends up being 9. And this is the equation. This right here. Now, if I wanted to pull information out of it, I would say that my center would be 4, comma, -1, and my radius would be 3. And given this information, I could graph quite easily. So I come over here, and I have my center point at 4, 1. There's the center. And now I'm going to count 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then 1, 2, 3. And here's my circle. And that's how you do this type of problem. All right, your turn. Go ahead and try these two problems. When the video plays, you'll see the answer for 3A. And then when the video plays again, you'll see the answer for 3B. Okay? Use the problem you just wrote down as the example. The pattern follows every single time. You may get fractions if you have an odd number, but otherwise the pattern is the exact same. Good luck. And here's your answer. So not much work done on this one. Just a circle with a center at the origin and a radius of 2. Okay? Good luck on 3B. And here's the answer to 3B. So in this one, remember you had to complete the square on both. So for the red one, for x, you take the middle term and divide it by 2, which gives you 4. When you square it, you get 16. 16 is what you're adding to both sides of the equation, because that makes it a perfect square trinomial and keeps the equation's golden rule same. When you factor the x down, this term will always be that one. It will always be b divided by 2 every single time. And the same thing goes for the y's. You take your negative 14 and you divide it by 2 and get negative 7. Okay, square it, 49. You add 49 to both sides of the equation. When you factor, negative 7 is what goes in the parentheses. Once you have in the parentheses, you're done. After that, all you need to do is pull out the information for the center and the radius if you're graphing. If you're not graphing, you don't have to do anything else. That's it. If you are graphing, then you're going to plot that point. So this is negative 4, 7. So this will be a bit off our graph, but it's okay. And then you plot the points. So you go down 5, 1, 2, 3, 4, 5, over 5, over in both directions, and then up 5. So again, a bit off the graph, but you can still kind of see what's going on here. And there's your answer. And that is the end of our lesson. If you have any questions, please let me know. Otherwise, make sure you have all the examples in your notes. There's a lot of moving steps on these, but once you understand them, they're fairly simple. All right, I'll see you next time in class. Bye.